In this video, we will talk about the importance of tuning LLMs for specific tasks and how to do it efficiently. It's an interesting thought to have a model that can handle everything. But in practice, LLMs come with their fair share of limitations. To increase their reliability and efficiency, LLMs need to be fine tuned for specific tasks and on specific domain knowledge. Just like a professional athlete specializing in their sport, these models need to refine their skills to master their performance. Let's start with a simple task example: question answering. This is a subdomain of natural language processing that's about automatically answering questions posed in everyday language. These Q&A systems are powerhouses, capable of tackling a range of questions, from factual to opinion-based, thanks to their extensive training on text and code. However, the secret ingredient for these models' success is domain knowledge. Consider this. When you're developing a QA model for customer support, healthcare, or supply chain, domain knowledge becomes a critical requirement. In customer support, a domain tuned LLM could provide insightful information on subscriptions and services, ensuring your clients receive efficient AI assisted service. In the realm of education, these models can offer detailed information about courses, tuition fees, or academic policies. For healthcare, they could serve as self management tools for patients, providing critical health related information. Retail businesses could benefit from better AI chatbots and product visualization, elevating the customer experience. And in the realm of supply chain management, LLMs could offer valuable logistics information and inventory insights. And let's not forget about the big tech companies. They could use these models to provide superior tech support to customers. Each sector has its own unique requirements, and tuning an LLM according to these specifications can drastically enhance the model's effectiveness. While generative Q&A models can use their trained knowledge base to answer questions without needing specific domain knowledge, fine-tuning these models on domain-specific knowledge significantly boosts their accuracy and reliability. It's like providing the model a detailed map of the terrain it's supposed to navigate. Take Vertex AI as an example. It provides task specific foundation models that are already tuned for a variety of use cases. Let's say you want to understand your customers' sentiments toward your product or services better. Vertex AI has a sentiment analysis task model that is just right for the job. Perhaps you're in the retail or real estate sector and you need to perform occupancy analytics. There's a task specific model designed for that as well. These models, honed for specific tasks, demonstrate the value of tuning. They're more efficient, targeted, and effective at their respective jobs. The ability to select and use a model that aligns with your specific needs can dramatically enhance the overall effectiveness of your AI solutions. Okay, now it's time to formally define what we mean by tuning. Tuning refers to the process of adapting a pre-trained model to a more specific task, such as a set of custom use cases or new domain, by training it on new data. Tuning is achieved by training the model on new data that's relevant to the task at hand. For example, if we're working within the legal or medical sector, we would collect training data from these domains to tune our model accordingly. But what is fine tuning? Think of fine tuning as a high precision adjustment to the model. You bring your own dataset and retrain the model, affecting every weight in the LLM. it can be a labor and resource intensive job and requires hosting your own fine tuned model. And that can make it impractical for many use cases. But it's important to know that a fine tuned model is equipped with a high level of accuracy and specificity. Let's take a real world example to illustrate the power of fine tuning. Picture a healthcare foundation model that has been extensively trained on a wide range of healthcare data. It can perform various tasks seamlessly, answering medical questions, analyzing medical images, finding patients with similar conditions, and much more. The reason behind its success is fine tuning with domain specific knowledge. By doing so, it becomes a specialist rather than a generalist, delivering precise and reliable results within the healthcare context. This process underscores the immense potential and versatility of tuning, transforming a one size fits all model into a highly specialized tool to navigate complex healthcare scenarios. Fine tuning is a great way to boost a model's performance, but similar to renovating a whole house, it can be expensive and not always practical. So, if we're looking for a more efficient way to tune large language models, what can we do? One approach to follow is parameter efficient tuning methods, or PETM for short. Think of PETM as giving our model a makeover instead of a complete renovation. Normally, with fine tuning, we adjust all of the parameters of the model, which is complicated and time consuming. But with PETM, we focus on changing just a small subset of these parameters, or even adding a few new ones. Maybe we add on some extra layers to the model, or throw in an extra piece of information. Figuring out the best way to do this is still a hot topic among researchers. But the key takeaway here is that PETM is like a shortcut. It helps us avoid the need to retrain the entire model, saving us time, effort, and resources. Plus, it even simplifies the process of using these models later on, as we just use the base model and add on our extra bits. We've now reached the conclusion of our exploration into the world of large language models. From this section, we've gained valuable insights into LLMs, starting with an introduction to their structure and function. We discussed the numerous benefits of using LLMs and provided some examples for them, including Palm, Lambda, and GPT. We also talked about the process of LLM development, highlighting how it's different from traditional machine learning development. And most importantly, we underscored the significance of tuning LLMs, diving into the ways it enhances their reliability and accuracy. We've seen how domain specific knowledge can significantly improve their performance and learned about efficient tuning methods like parameter efficient tuning methods. In the next section, we will familiarize ourselves with four major tools on Google Cloud that enables us to access and fine-tune generative AI models and build our own generative AI applications.